Today let's try to solve another Leetcode problem, 2360, longest cycle in a graph. So we are having a directed graph of n nodes. So it is starting from 0 to n minus 1. So we're going to use this example. The graph is represented with a given 0-indexed array axis of size n. So this means the size of the axis is the number of vertices of the graph. So for example, for the first example, index 0 to 3, it means the index 0 node connected to 3. It is a directed graph, and node 1 connected to node 3, node 2 connected to node 4. Yeah, it's like that. If there is no outgoing axis from node I, then axis I equal to minus 1. So for this example, if it is minus 1, it means for node 1, there is no outgoing axis. I think this one is also very important for us to solve the problem. Each node has at most one outgoing axis. So in this example, we should know about that. So each of the node can have 0 or 1 outgoing axis, but it cannot have more than 1. So for example, this node has 1 outgoing axis, or we can draw another node. Let me prepare maybe red. Or maybe we have another node here, and this is node 5. So this node has no outgoing axis. It is okay, but this node has 1 outgoing axis. It is still okay. But for example, this node 4 cannot go out like there's another cycle. It will not like that. Because each of the node can at most have 1 outgoing axis, but this node have 2 outgoing axis, so that is not possible. So we don't have such cases. Otherwise, it would be much too difficult. Now let's just continue to check the problem. We are going to calculate the longest path in the cycle. Let me check. It is the longest, not the shortest. We are going to check the longest path in the cycle. So for example, this cycle is 3, so we're gonna return a 3. But for the second example, this one, there's no cycle, so we're gonna return a minus 1 if there's no cycle. So the problem would always be like that, according to the description of the problem. So it will always have a cycle, or there's no cycle just like that. There are two cases. If there's no cycle like that, we're gonna return minus 1. If there is a cycle, we're gonna calculate the longest. Or inside the graph, there may have 2 cycles. So this is 1 cycle, maybe the length is 3, maybe this cycle, the length is 4. It will have different cases. So there is some node and go inside, and here also some node go inside, and here also some node go inside. So the graph will basically like that. We are going to calculate the longest cycle. I think the easiest way to solve the problem is by using topological sort. By using topological sort, we can remove all those edges which is connected to the cycle. We can remove all that. And here we can also remove that. Because while we are using the topological sort, we're gonna use the BFS plus the topological sort. So while from the beginning, like in these areas, the integrate is 0, so we're gonna remove the edge, and here also the same. So if the integrate is 0, we're gonna remove the edge. Now what's left behind? It is a cycle. Maybe this is 3, another is 4, but we are going to calculate the longest cycle. So the problem left behind is how to calculate the cycle. So this is like a cycle chart. In our integrate array, we have an integrate array. There will be, I will just give a rough example. There will be some integrates, maybe 0, 0, or maybe there is some integrates, it's gonna be 1. So for example, from node 2, 3, and 4. So here is like node 2, this is node 2, and this is node 3, and this is node 4. So inside the integrate array, if the degree is if the integrate is 1, it means there is there is outgoing integrate is 1, it means the integrate for example for this node the integrate is 1. There's only one edge connected to it. The integrate is 1. Yeah, it means those integrate of 1. It means 2, 3, or 4 may become a cycle. Yeah, we don't know, but if it is 1, it means we can use this integrate 1 for the cycle check. For example, if the node 2 with integrate 1, so we're gonna start from this point. We're gonna check the length of the cycle. So this is just a cycle check function. For the cycle check, we are giving these edges. It means the connection of the edges. We can use this edges array to check the length of the cycle. So from beginning, for example, this is I. We're gonna use a variable x equals to I, and we're gonna use a variable cycle equal to 0 to check the cycle. So we're gonna use while true. We're gonna check to the next, until we got our updated x equal to I. This means we've already checked the cycle, and also we recorded the length of the cycle, maybe updated to 1, 2, or 3, and we're gonna return 3. Or maybe we're gonna check this cycle, it is 4, so we update the result, it's gonna be 4. Yeah, here may be a little bit hard to explain, but basically the idea is to calculate the length of the cycle with a given integrate array. If the integrate is 1, we're gonna starting from this point to check. Yeah, after updating, this integrate will become 0. Maybe there's the integrate array, there's another node with 1s, so we're gonna check another cycle, this one here. After that, we're gonna update the integrate to 0. Yeah, we finished the check. We're gonna return the final result. It's gonna be 4 because this is the longest. Now let's just finish the coding part. Yeah, I think the rough idea is very important for us to solve the problem. We need to have a basic idea about which proofs we're gonna use to solve the problem. We're gonna use a topological sort with the cycle check. For the topological sort, I'm gonna need an integrate array. It's gonna be 0 times n. So n is the size of the edges, so it's gonna be the length of the edges. Now I'm going to check the integrate for each of the node. So I'm going to check the integrate. So for uv in enumerate the edges. Yeah, because these edges can use enumerate. This means from u to v connected. So the integrate, it should be v should be plus equal to 1. Yeah, but for this integrate, some of the v may be minus 1. We need to be careful about that. So we have to check this v. If v more than or equal to 0, it means it is a valid integrate. So we're gonna plus minus 1 for this integrate. If it is minus 1, so this minus 1, it is not a valid node, so we don't need to check that. So this is the preparation for the integrate. Now we can have a queue. So it should be the queue. So inside we're gonna prepare all the node with integrate of 0 because we're gonna start the BFS for the topological sort. So I for I d in enumerate the integrate if this d equal to 0. Now we are going to start the topological sort. We're gonna have a node should equal to q dot pop left. Yeah, so for this example, for example, the integrate is 0. We're gonna start for this node 0 and then node 1 until we finish the topological sort. After finishing the topological sort, all those nodes will be disconnected. So from here, it will be disconnected. What left behind is just 2, 3, and 4. It's a cycle. So we're gonna check the length of the cycle. So I pop out the node, and then I'm gonna check the neighbor. So the neighbor would be easy, just as is with this node. Yeah. And also for the neighbor, I need to check the neighbor. It must be more than or equal to 0. Because, for example, this neighbor is minus 1. It is not valid. Yeah. So if the neighbor is more than or equal to 0, I'm gonna check. So the in degree and neighbor would be -1. This is just the topological sort part. I hope you understand the basic template of a topological sort. So it's a in degree with neighbor equal to 0 q dot append with this neighbor. Let me just print out what's gonna happen. So let me just print out what it looks like for the for the queue after finishing all those topological sort algorithm. There's something wrong. This is a if tag syntax error. Now let me check the result. What is the queue inside? Normally I don't need to check the queue. Queue should be empty. I need to check the in degree. Because I will use this in degree array to check the cycle. So I need to make sure this in degree should be right. Let's just check the first example. It means 2, 3, 4, it should be a cycle. As you can see here, 2, 3, 4, the in degree is always 1. It means 2, 3, 4 may become a cycle. And 0 and 1, in degree becomes 0. It is 0. It means basically this in degree is right. As you can see also from here, let's just check the in degree before the BFS part. So before that, as you can see, the in degree is 0, 0, 0, 0, and this is 1, and this is 3. So for node 3, in degree is 3. So after that, you can say after the topological sort, this one still 0, but here this 3 becomes 1. 1, 1, 1 may become a cycle. So this is why we're gonna use the topological sort to check the in degree array. And the next step is we're gonna check the cycle. So the cycle tag, I'm gonna define a function called cycle, and inside it's gonna be array. Finally, I just need to return this cycle with in degree. So this will be my final return. Currently, I just need to finish this cycle tag. So for the cycle tag, I'm gonna prepare a result because the result may be -1 if there's no cycle. So my return would be this result. Now let's just finish the main part of the cycle tag. So for I, D, still enumerate this in degree. I will check this in degree if this D equal to 1. As I printed earlier, if this D equal to 1, it means it may be a starting point of the cycle. So we're gonna start from here, and then we're gonna check the length of the cycle. After visiting this node, this in degree will become 0. Currently it is 1, but I will make it to 0, and so in this way the time complexity will be O(n). Because the n is 10 to the power of 5, we have to use O(n) to finish it. Now, if this in degree is 1, I'm gonna start the cycle tag to check the length of the cycle. So I'm gonna use x as my starting point, and a cycle variable or answer variable or cycle variable as 0, and x equal to I, because I'm going to start from this I to check the length of the cycle, and the cycle currently I will give a 0. So while true, I will use a while loop to check this cycle. So while true, so the cycle should plus equal to 1, and x should equal to as is x, and also in degree with this x should -1. So for example, we are starting from this node 2. We're gonna start the this is not it is node 2. I think while we are checking this in degree from here, it is 1. So we're gonna start from this node 2. So while it is true, so my cycle would +1. So my cycle from 0 is gonna become 1, as you can see from here, and then x should equal to add this x. So the x should equal to 4, and in degree for this 2 would become 0. So it means here would become 0, but my cycle length has become 1. And then from 4 to 3, the cycle becomes 2, and then 3 to 2, the cycle becomes 3. It means I've already finished the attack. But how can I stop the while loop? I need to break it. So if this x, currently this x updated like 2, 4, 3, and 2, this x equals to 2 again. So if x equals to I, because here x equals to I here. Now finally I have to check if this x equal to I again. If it is equal to I again, it means I have to break it. But before break, I need to record the result. It should be maximum of result with the cycle, and then I need to break it. So this is the entire code. I hope everything should be right, but now let me just run it to check. As you can see, it is okay. Now let me submit it to make sure everything works. Now as you can see, it works and it's pretty fast. The time complexity is just O(n). N is the length of the array, 10 to the power of 5. The difficult part of the problem is that we need to understand the basics of the structure of the problem. The structure can have a cycle or no cycle. We just need to check the length of the cycle. We can use a topological sort to prepare the in-degree array. After preparing the in-degree array, we can use this in-degree array to check the length of the cycle. And for length of the cycle, we just needed to check if the in-degree equals to 1, we're gonna start to check. Because the in-degree can only become 0 or 1. So if it is a 0, if it is a 0, basically means this node is not inside a cycle. If it is 1, it means inside a cycle. This is why we're gonna check for the in-degree equal to 1. So this D just means the in-degree. If it is equal to 1, we're gonna check the cycle. So this is the entire code. Thank you for watching. See you next time.